Example 7. So imagine you have an engine that is operating like an ideal Carnot engine. And it's operating at temperatures of 850 Kelvin and 300 Kelvin. And that means that the hot temperature of the reservoir is 850 Kelvin. And the cold reservoir has a temperature of 300 Kelvin. And the engine does 1200 joules of work, so W is 1200 joules. And it does this in a time of 0.25 seconds. So in part A, we're asked to find the efficiency of this engine. And since this engine is operating on a Carnot cycle, we're really finding the Carnot efficiency. So the Carnot efficiency, if you recall, is TH minus TC divided by TH. You could rewrite this, if you wish, as 1 minus the ratio of the temperature in the cold reservoir divided by the temperature in the hot reservoir. And remember that these temperatures must be in Kelvin. Okay? So now let's substitute in. We have 1 minus 300 Kelvin divided by 850 Kelvin. And that gives us an answer of 0.647, which is roughly 65%. So that's the maximum theoretical efficiency. In part B, we're trying to find the power. Capital P is the formula for power, is the amount of work done per cycle divided by the time that each cycle takes. So the power of that cycle would be 1200 joules of work was done in a time period of 0.25 seconds. That gives you an answer of 4,800 watts. Or you could rewrite this, if you'd like, as 4.8 kilowatts. Now in part C, we're asked to find out how much energy, QH, is extracted as heat from the high temperature reservoir for every cycle. Now remember that for any engine, including a Carnot engine, the efficiency is the ratio of the work done per cycle divided by the energy input as heat. So E is also equal to, for any engine, W, absolute value W, divided by the absolute value of the heat input. So we'll rearrange for the heat that is input into the engine. So that would be W divided by the efficiency. And so that would be W is 1200 joules, and the efficiency of the engine is 0.647. And this gives us an answer of 1,855 joules. Now maybe as an aside, we'll ask one more question. How much energy would be delivered as heat to the low temperature reservoir? So what is QC equal to? Remember that for a Carnot engine, the work done per cycle is equal to the difference between the energy input minus the energy output. Therefore, the energy output would be equal to the energy input minus the work done. So that would be 1,855 joules minus 1,200 joules of work, which gives us an answer of 655 joules are expelled to the cold reservoir. We'll just call this part D, since I didn't ask that, but it would be a good question to ask. And that's it for example number 7.